Next speaker, Xiangyun Lei on fingerprinting and visualizing electronic environment.
Thank you and good evening. My name is Ray and I come from the chemical engineering department. But I don't work with the actual chemicals. My job is running experiments on the computers so we can save the time and money on the lab. More specifically, I calculate the energies of chemicals and reactions so we can know whether a chemical could be made and how to make them. Unfortunately, as much as I like to, we're only able to study very, very small systems or very, very small chemicals. So why is that? To see the reason, let me give you some background. So we know everything consists of atoms, and when we think about atoms, we tend to have that picture in mind. That electrons orbiting around the nucleus, like planets orbiting around the sun. But that's not the case. Instead, electrons form a cloud around the nucleus. For example, this is a realistic visualization of the electron cloud of carbon dioxide molecule. You see the cloud has different density at different spots, and it is this density and how it changes around defines the electronic environment of a spot. And with different environments, we have different energy, as you can see. So if we could know the energy of all the spots in the system, we will be able to calculate the total energy that we really care about. And we have this wonderful theory called DFT that can take us from here to here pretty accurately. But it's very expensive. Why is that? The reason is, let's say this room is a system, and I want to calculate the energy over here. I have to consider every other point in this room. Why? Because DFT is treating it as if it's like the first time you see such environment. So it has to consider influence from every other part of the room to get the energy over here. And then remember, you have to repeat the same process for every single point in the space to get total energy. You see, this makes it extremely expensive to calculate the energy of the system, especially as the system gets larger. But that doesn't make sense. First, we're not always seeing new, unique environment all the time. Instead, we have the same environment across different chemicals. Also, something happening over here shouldn't depend on something far away. It should only depend on its neighbors. So how can we make things better? My answer is fingerprinting the electron environment. So what do I mean? So right now, for every spot, I just look around and ask myself, how much does it look like a sphere? I evaluate it and give it a number. Then how much does it look like that thing over there? I evaluate it and give it a number. So after the whole sequence, I get a sequence of numbers that I call the fingerprint of the electron environment. With this fingerprint, I could give it to an AI model that has already seen a whole bunch of different environments and ask it for its corresponding energy. You see, in this way, we'll be able to dramatically lower the cost of DFT calculation, and that will allow us to speed up things in the future. Thank you very much.